Hi everyone, welcome to Introduction to Corda. My name is Irina and I'm the evangelist here at R3. And I'm presenting today with Anthony.
Hi, everybody. I'm Anthony. I'm also a developer evangelist at R3, and I'll be doing this with Irina. Oh, here we go. Okay, so I can see the screen.
So Corda is an open source blockchain platform for business, and this presentation is for developers who are new to Corda or even to blockchain generally and want to understand more. You can join us on Slack at CordaLater at slack.corda.net, a place for interacting with the broader community. You can find Corda Docs, a brand new free training site, or you can tweet us at Corda blockchain. So what this introduction we're going to cover? I will start with a brief overview of general blockchains, their advantages and disadvantages, how Corda differs from other blockchain platforms, quick overview of our company, high-level overview of the main Corda components, and we finish with a small example. So let's start our presentation. At Corda, we believe that distributed ledger technology reduces cost and time to market while increasing the speed of business. A lot of people asking what blockchain technology can do is not necessarily creating profit for you, but reducing friction between businesses and actually save you money. So what are the issues with the traditional blockchains? Why this is a problem? So there is a problem with identity. There is no strong identity on the blockchain. You don't know with whom you transact. Every participant is pseudonymous. You could only see a public key of your counterparty, but you will never find out who they are. So when you have to send money to them, you have to send money to their public key. From individual point of view, that might be just fine. But from business point of view, this is not acceptable scenario. You have to know with whom you are having business. Second issue is the privacy. There is a great transparency in the traditional blockchains, which is great in some cases. But businesses usually don't want to broadcast their transactions to everyone on the network. Although data encrypted and hashed, but it has a small probability that the data can be decrypted. Why speed is important? Why there is issues with speed? Because each node have to process all of the transactions, and also due to design of the blockchain, where double spend is prevented by artificially slow creation of new blocks. So the system has time to check all transactions in recently added blocks for double spend. As we all know, double spend is the number one issue with the blockchain. We need to make sure that the money we have is not spent twice. And we really want to make sure that the counterparty's monies don't spend twice either. And lastly, integration. Why we need integration at all? So blockchain doesn't form the entire application. It needs to communicate with the multiple other applications. For example, if you're making payments on a blockchain, then blockchain platform needs to communicate with the core banking system. Therefore, integration is important, and traditional blockchains are unable or very technically difficult to integrate with existing software systems. For example, it's difficult to integrate Ethereum because it uses completely different language. And so developers has to write integration layer that talks to a node via WebGL3.js. During design, what is now of Corda, what we were really doing, looking at what kind of opportunity this technology might bring to financial industry, and that might create cost savings and efficiency. After considering the traditional blockchains, ultimately we realized none of these technologies can be adapted no fit for you for our use cases, and we had to build what's now known as Corda. But we did take some blockchain design features. So what is our version of blockchains? Let's look at Corda. So Corda is a blockchain for banking, uh, but uh, uh, but this is common misconception. We are not only doing banking. There are many projects in insurance world, logistics, supply chain, healthcare systems. But it's also blockchain for business. It's platform built specifically for businesses and now offer privacy, scalability, and interoperability. It
So there's
also
also a question related to this, what you're talking about, Irina, is that somebody asked, does Corda use a cryptocurrency? And I think basically in line with what you're saying, how this is sort of agnostic to the use case, you can use Corda for any type of business, whether that's regulated or whether that's sort of just a simple peer-to-peer supply chain case, or maybe also a service industry, etc. So when you say cryptocurrency, the first and second generation blockchains had a lot to do with just specific transfer of digital money or like cryptocurrencies, but Corda, as a general purpose use case platform, you're not only held to just transferring, say, like tokenized digital money, etc., or cryptocurrencies. There's actually no native cryptocurrency such as a utility token or some sort of like digital exchange medium, but it is possible to do. So it's really up to you what sort of use case you want. If you want to develop a native cryptocurrency on Corda within your network, you can do that. But otherwise, it's completely agnostic to your use case. So you'll see, as Irina points out more, on the evolution of the design and how it was planned for business, how you can kind of apply it to any sort of use case or scenario. So I'll pass it back to Irina.
thank you, Anthony. So it's also Corda is a at Corda we try to create a cross-industry ecosystem, but there are also many financial projects with Financial Fusion, Lender.com, and SIX, which is Swiss Exchange. We create a DLT system and not trying to create another silo. We want to create a large global ecosystem where financial, insurance, and supply chain companies are on the same network, where solution providers and regulators are involved. So the story of R3 and Corda. R3 officially launched in September 2015. There were a small number of banks, which grew to a large number of banks, from 9 to 42 in just a couple of months, based on their fear of missing out. And now it's grown to hundreds of institutions who are part of wider R3 and Corda ecosystem. That's when we decided to design our own version of DLT that fits for business needs. If you fast forward to November 2016, when we first open sourced Corda, and jump in a couple of months ahead of beginning of 2017, we made a very important decision for the firm that we were going to pivot away from the consortium and going to be a platform company and focus on building enterprise software. When I say enterprise, it's compatible with the open source core with additional benefits such as tooling to help enterprise to deploy and manage DLT. And that was Corda. The real implication of that in 2017 was need to recruit a large number of people who come and build a whole stack of applications that make Corda valuable to the users. From that point through 2017 and 18, our main focus was to build Corda and getting the enterprise version to the market, and creating that ecosystem of partners to build applications that really brings value to the platform, and get those applications into production and into hands of end users. Up until today, and that have been continues to be our primarily focus. If I flip on where we are today, that ecosystem that starts as 9 banks grew to 49 and continues to grow to up to 350 participants. It includes regulators, central banks, ISVs, independent software vendors, building applications on Corda, which is called CorDapps. Advisory firm, top-tier consulting firms. It includes the world's largest system integrators, the biggest cloud providers, hardware providers. This is everyone who is contributing to R3 Corda ecosystem. Our initial Series A was $120 million in funding. At that time, it was one of the largest series ever raised. We have over 310 employees in 14 countries. Thousands of developers contributing to Corda open source, and there were 3,000 certified Corda developers in 2019 alone.
So our introduction today that we're going over, this slide is especially relevant to it. So we're kind of getting you all primed and comfortable with Corda so that you can continue on from a developer perspective and start to build applications on the platform. But this particular slide here also highlights the many different avenues that you can participate or engage in this cross-industry collaboration and find, like your own business solutions or apply it to your company's goals. So if you're actually maybe a banking industry or you're involved in some sort of like structure or consortium based industry, whether it be insurance or whether it be something like a supply chain, et cetera, then you think of yourself as sort of an ecosystem participant. You're going to be forming these networks and rapidly scaling and improving the efficiency of your workflows and of your business processes. But you can also, I'd imagine that some of you in the audience are sort of like software developers, part of an ISV. Maybe you want to launch a startup or you want to build custom solutions. You can kind of get involved in this area of CorDapps, where we actually have a marketplace which is out there and ready to deploy CorDapps, which can be utilized by ecosystem participants and bring in a monetary stream of income for you. We also have developer partners. This is more like system integrators. So you see here on the screen, we've got stuff like Accenture, Ernst & Young, et cetera, et cetera. So these are companies that are specializing in delivering enterprise solutions on demand. So when a company wants to start using blockchain and they have no clue how to do that, then you'd have to come in, have a team ready to deploy a solution. Corda is actually very, very beneficial for this particular area because of the interoperability and the existing integration with legacy systems. You can kind of give a value proposition to your clients to say like, hey, we can get this system up and running quite quickly in a quite cost-effective manner, and it's going to be solving all of the issues which you hope to address with a new blockchain system. And then infrastructure and tech partners is allowing an extension or addition of choice for the different companies out there that wish to deploy Corda, because we're not actually stuck to a single type of infrastructure. You can deploy on Azure, you can deploy on a Google Cloud, et cetera, and you can plug in your existing database system. So it's very flexible in that case. So moving forward, Irina will talk about how this unfolds from here.
So thank you. So with the Corda, we refocus the idea of public blockchain, make it private blockchain, focusing on strong identity. That means that we know anybody who gets into the network because they have to get approval by the network operator. We focus primarily on the privacy. On the next slide, we're going to see Corda communication is peer-to-peer. In traditional blockchain, all parties have to reach consensus. In Corda, it's offloaded to notary, which we're going to look later. We achieve performance and scalability by design with Corda Enterprise. We have very high transaction speed. And with interoperability, it's suitable to do in Corda, and there are several projects that are in process. Lastly, there is a Corda core, which is open source. Corda network and testnet is just help to everybody to get feeling of what real network hub is, which is free to use as well. It's useful to think of Corda network as fully connected graph, where all the nodes on the graph are actual Corda nodes. Each node represents any individual or organization, but typically they represent legal identity, and each runs the Corda software, an instance of Corda and one more Corda applications known as CorDapps. The edges represent the potential for the nodes to communicate. All communications between nodes is point-to-point. This means that data is shared on need-to-know basis. However, if required, then data can be broadcasted to multiple parties, but it's not the default way of sharing data on Corda. All of the nodes in the network have potential to communicate with other nodes. So as long as you can see another node, you can message to it. And you always have to know destination of the message and send it directly. Transactions completed and stored only to participants who were involved with it. For example, here, if Titan Partners and Colorado River Authority make a transaction, then only they have a copy of this transaction. And Base Transcorp weren't even aware about this transaction. So the crucial point from this slide is to understand that Corda is different from other distributed ledger technologies that uses global broadcasting and gossip network to propagate the data around the network, where Corda uses point-to-point messaging. And notary pool means that it can be multiple notary nodes, and you can have just single node in it. So we'll talk later. We'll look at it later on next slide. So let's zoom out a bit and look at the Corda network. So over here you see Identity Manager, which is a service that onboards nodes into the network. You might think of it as a doorman. It issues certificates to verify permission network participants. There is a network map. You might think of it as an address book, which is available to all nodes on the network and allows them to find and interact with other counterparties. There are notary operators, it's organizations and entities providing notary services, uniqueness consensus on the Corda network. So it could be contributed service, a pool of counterparties running on a pluggable consensus algorithm, can be regulator, trusted third party. There is also Corda and Corda Enterprise. So participants are free to choose either Corda Open Source or Corda Enterprise. I will repeat again that Corda Enterprise is compatible with open source core with additional benefits such as tooling, additional deployment options, network management, SLA guarantees, support, and more. Both versions can coexist, and they are also maintained in separate code repositories. And there is an option of migration path from open source to Corda Enterprise. And there is also token SDKs and Corda Settler. Corda has standardized APIs and settlement options, which facilitate interaction between unique business networks and codes.
So just in addition now, I'll explain a little bit so everybody can visualize how the Corda network works in a deployment scenario, or when you're actually putting this out into production in the field. So you'll know that from the previous iterations of blockchain and from the permissionless public blockchains that there's that global network which everybody is a part of when they're doing transactions, etc. Corda is specifically suitable for enterprise in the fact that we make it exceptionally flexible in how you want to see this realized in your actual production. So a Corda network by itself is something that's self-contained, and it can be something that you can do on your own. So privately, you could have your own regulated, say you're in a regulated industry that has very strict rules in terms of membership and also privacy and permissioning, etc. You can deploy your own private Corda network. So using your Corda open source or your Corda enterprise, you can set up your own identity manager. You can set up your own KYC process and onboarding, and you can explicitly control at the network level like who's a part of this, and nobody else will even know that Corda network exists. So we have a lot of Corda open source users around the world, and we don't even know how many Corda networks are in operation today, because if you decide to deploy your own network, basically nobody out there is aware of it. So you have full control there. But we also offer an analogy to those permissionless public networks, which are permission and have all the same like enterprise features. So we have something called the Corda network, which is a global managed network, which is actually run by a nonprofit. So R3 is the current maintainer, but there's a board of directors. It's completely autonomous, and it's meant to basically be a sustained network which can allow participation from all types of business verticals around the world and all types of industries and countries and individual nodes. So that's an optional way to go for the future, or when you're thinking of deploying your solution. So it's really up to you what you choose, but in both scenarios, you're going to have this basic like overall architecture. So that's kind of what you need to know in terms of the network. And if you look at the notary operators, the little yellow dots on the screen, and then the nodes, the green dots, that's kind of like the simplified version of the slide that we saw previously. So we had that sort of abstract view slide, and then we saw the full Corda network slide. So with that in mind, we can continue on with understanding node operations, etc. So Irina, up to you.
Corda nodes run within a Java virtual machine. All the benefits of distributed ledger technologies properties are made simple by abstracting away detail. So all distributed system cryptography and data management are completely hidden away from the user. Developers can quickly accomplish tasks through extendable flow library, which performs standard tasks with very few lines of code efficiently. A Service Hub API allows interaction to call DLT functionality on the node. Typical use case for Corda is to allow different organizations to message each other and transact with each other. This is essentially a shared fact, piece of data that doesn't exist in a central repository, but instead exists in all nodes that participate in this event. And flow is an entry point for your CorDapp. Think of it as a function that you can call via API. And steps in the flow reflect business logic of your CorDapp. So let's look at the notary. One obvious question is, if data is only distributed on the network on need-to-know basis, how do we prevent double spends? How do we prevent some node transferring some digital to one party and then turning around and also transferring it to another party? In Corda, we prevent double spends using notary pools. We have a strong pluggable consensus since users operate under a diverse set of trust assumptions. Consensus algorithm that we use are Byzantine fault tolerance, which runs at lower speed but assumes lower levels of trust between parties. Conversely, parties can choose to use an algorithm called Raft, which executes at high speed but assumes high levels of trust between parties. Corda uses the UTXO, unspent transaction output model. The reason UTXO deals with inputs and outputs is that currently stored facts are immutable and cannot be changed. This ensures that the history of the fact holds its integrity. So in order to commit a change to this fact, we create a copy of or new instance as an output. The input is marked as a historic and can be referred by, but never used again. And the output is now the fact. So transactions are first proposed. A transaction contains input, records which wish to be changed, consumed, output, records containing the applied changes. Outputs then become inputs for future transactions. And the notary makes sure no same record can be changed twice or double spent. By keeping a running list of each input ever consumed on the network and checking future transactions against in the list. If an input is not unique, the transaction is rejected.
So I'll just take 1 second here to kind of expand this into a practical sense, because the notary system is actually one of the best benefits of going with a permissioned private network, which is Corda, because what it does is it offsets, like Irina said earlier, when you have those permissionless public blockchains, the way that things are kept in sync and the way issues and tampering such as double spends is handled is by having this global record, which actually has a humongous performance impact and sort of limits your throughput and your applications to real world problems, because legacy systems which are not on blockchain obviously have risen to the point where they're able to handle exceptional high capacity. So we wanted to make sure that corporations and entities that need it were able to leverage sort of like the same quality and the same performance. And the way we did that is by taking into account that in the business world, there's natural hierarchical trust structures. So it's not necessarily the sense that we need to have every single entity on the network, kind of like always conferring with each other, passing messages for consensus, you can delegate this sort of like trust or the responsibility of checking for double spends to some sort of entity. And in a regulated market, that might be something like a central bank, et cetera, where all of the different regional banks are held accountable to, or it could be something like even in a consortium or a network of counterparties that interact regularly. They can set up something like a notary cluster in which they run a consensus algorithm among their contributed hardware. But the key thing to note is that the notary, whether it's individual or whether it's a cluster, is going to have a single identity on the network, and that's going to be able to things like double spends and make sure that transactions are signed as valid after they've been checked. Now, for record consensus between counterparties, you obviously have signature constraints, and you're going to be proposing transactions, as Irina said, and then only if you are agreeing to and you're comfortable with that particular transaction proposal will you sign on it, and then after all parties have signed, it goes to the notary for a timestamp and final signature. So that's kind of how it works, and that allows us to reach transactions per second, which are basically up to this point somewhat unbounded. It's more about how much hardware you want to scale rather than something that's a limitation of the network paradigm or the code itself. So Irina will continue on.
Okay. A quick look at our CorDapp. So CorDapp consists of states, which represent here as a cars. Our contract is used to enforce rules on how we can operate business. Flow, which is our business logic. And when we trade, the first step, we propose a transaction to our counterparty, or then we verify it. And our process is on through our contract to make sure that it's a valid transaction. Then we sign it and send to our counterparties for signatures. Counterparties validates it, signs it, and send it back. Initiator then send it to notary for authorization. After notary checks for double attempts, and it's fine. Notary will sign it and send it to initiator and all counterparties. And once all counterparties have received the transaction, they updated their own databases.
So that's the basic sort of CorDapp in a nutshell that Irina just talked about. And the last thing I think we want to leave you with leading into your own sort of investigation and your participation in further events such as the bootcamp, where you'll actually learn how to program one of these CorDapps, is kind of how this CorDapp structure fits into a real world use case, or how it can be applied to your own sort of goals as a business or an entity. So right here, like on the screen, you kind of see that it's states representing a car or a particular like item, which is a seller, a buyer, and a model, etc. So when you want to share a fact between counterparties, something that is regularly in transition, whether that's like a receipt or whether that's an on-ledger digital asset, etc., you would bake in that data or represent it as a class, which is the state. So the state is going to be the shared fact. The contract, what it is, it's the rules that your group or the agreed upon rules between all the CorDapp users on how that state can change or how the fact can be evolved over time. So that's something where you would put in, like that the model cannot change, because obviously you don't want to say that I sold this car and now it's all of a sudden it's a different car. So you can put in constraints like that. You can put in constraints like only these certain institutions are allowed to buy or to sell or to transact. So these sort of common business rules. And then the flow is kind of what takes in that both the shared fact definition as well as the contract, and allows you to actually build a transaction, pass messages across the network, and interact with your node, as Irina described with the flow framework. So when you see these little on the map here, those are sort of messages happening and transactions happening. That would all be orchestrated through the flow. So that's where your program logic is. Now, if you're used to Ethereum, etc., their idea of a smart contract encompasses all of those concepts together, which has a little bit of a limitation because it makes it a little bit more verbose and more prone and kind of a little bit less flexible in terms of doing things like sort of like extending or reusing code, etc. So we abstract these these concepts into different discrete entities. And it allows you to not only develop faster, but also communicate and sort of design in a more practical mode, because it sort of like gives you the way to interface with, say, like your project managers or your business stakeholders to say like, hey, these are the common rules. Hey, this is what's happening in terms of the transaction, and this is the actual fact. So you're going to find that a benefit as you develop. So Irina will explain where to go from here and how you can get further into this.
So yeah, so we prepare next workshops, which will be a bootcamp workshop on next Thursday, and then accounts and tokens workshops. So please join us for next bootcamps. Thank you so much, and see you later. Bye.
Thanks, everybody.
So yeah, it's